Okay, now we are looking at the reduction formula. We are looking at the reduction formula. So when you're looking at the reduction formula, remember we said we cannot integrate sine squared x dx directly, right? A trigonometric function raised to a power that is greater than 1. We cannot integrate this directly, so we need to reduce this power using what? We need to reduce this power using identities, right? So, but there is a formula that we can use to solve this directly. It's called the reduction formula, whereby we look at the integration. Let's say the integration of sine n x dx, where n is a member of positive integers. N is a member of positive integers. Right. So here we are saying whatever value of n that we have, we can devise a formula that we can use to evaluate this integral. So it can be also cos nx dx, the integral of tan nx dx. So these are the first three that I'm going to look at. How are we able to devise the iteration formula for all of these three, and how we can actually apply them given scenarios and equations. So first of all, we are going to look at the indefinite integral, and also we're going to look at the definite integral, where we'll be evaluating from pi over 2 to 0 of sine nx dx. This is the definite integral. So how to evaluate the integral of sine nx dx? So remember, we are reducing n to a form that we can integrate, right? It's the reduction formula, so we are reducing the power to a power that we can work with, right? To a single power. We are reducing cos nx dx to a form that we can normally work with, such as cos x dx or cos dx. We can evaluate this, but we cannot evaluate cos raised to the power n, especially when n is greater than 1. So there are formulas that we can derive called the reduction formulas that can help us to solve questions like this. So these formulas can help you to evaluate even expression like cos to the power 10 dx at ease, without the need for you to use identities and expand everything. So like, let's start. In this video, I'm going to look at how we are going to find the reduction formula for sine nx dx, and allow me to say this is in. So in is equals to the integral of sine nx dx, where n is a positive integer. Okay, so from here, what do we do? From here, we are going to split this sine n. I'm going to factor out sine x from sine n, sine raised to the power nx dx. So we're going to have in is equals to the integral of sine. If we factor out sine x, we're going to be left with sine n minus 1x, right? Sine x dx, because this is raised to the power 1. So if we can also multiply these two, we are going back here, right? So now we have factored out sine x, right, from sine nx. So now we have two functions here, and then obviously if you have two functions, we use what? We use integration by parts. But then the trick part is here. How do you determine u, right? Because remember, the integration by parts, du is equals to uv minus v du, or this is dv, right? So this is the formula. So how do you determine u? So here, remember, this is the reduction formula. So when you are using the integration by parts, we are integrating. Remember, you are integrating, and also you are differentiating derivatives, right? So remember, we want to reduce this power n to a form that we can work with, to the simplest form, right? To the simplest power. So which between integration and derivative, which reduces a power? We know that is derivatives, right? So that's why we are going to say this is going to be u, because we know that if u is equals to f of x, then du dx is what is f, that's x, isn't it? So when we chose u, we differentiate u, we integrate v, right? We integrate dv when you're looking at the integration by part. So our u here, because we want to reduce the power, is going to be, u is going to be sine n minus 1x, and then dv dx is going to be sine x, right? So from here, you just work it the same way when you're looking at integration by parts. So this is du dx is going to be n minus 1 sine n minus 2x times, remember, this is to the power, which means you integrate the outer, you differentiate the outer sine function and also the inner sine function. If you differentiate the inner sine function, you're going to get what? You're going to get minus cos x, right? Because we're integrating sine x, we get we are differentiating sine x, we are going to get positive cos, and then if we are integrating sine here, we are going to get your v is going to be minus cos x, right? So now we identified u and we identified dv dx because we're using the integration by parts, and we said we are saying u is equal to sine to the power n minus 1x, because when you are differentiating, the power will reduce. Thus we call this a reduction formula, right? We want to reduce the power so that we can be able to work with the final expression, to integrate the final expression. So if we are using our formula, if you're using the formula v du, this one, so the integral of u sine n minus 1x dv, which is sine x, this is equals to uv. What is u? U is sine n minus 1, and then v is minus cos x, which we got from integrating both sides here. We got v to be equals to minus cos x, and then minus the integral of v. What is v? It's minus cos x, right? And then du, this is du, right? Which is cos x n minus 1 sine n minus 2x dx, right? So if we, let me just rewrite this expression. This is sine n minus 1 sine x is equals to minus cos x sine n minus 1x, then minus is what? It's plus, and then I'm going to factor out n minus 1, and then the integral cos is what? It's cos squared x, and then sine n minus 2x dx. Remember, this is in is equals to this, right? So now in is equals to, this is in, we said this is in right from the beginning. So now you have this expression, right? So you need to further simplify this. So here we have cos squared x. So let's represent cos squared x in terms of sign because we have sign here. So we know that cos squared x is equals to 1 minus sine squared x, isn't it? So that's what we're going to do. So in is equals to, so your in is equals to minus cos x sine n minus 1x plus n minus 1. The integral of cos squared x is 1 minus sine squared x sine n minus 2 x dx. So this is where we are. And then you're going to multiply with, you're going to open the bracket using sine to the power n minus 2x, right? So if we further simplify this, minus cos x sine n minus 1x plus n minus 1, the integral of, so if you open the bracket, you're going to have sine n minus 2x, right? Because this multiplied by this, you get this, right? And then now this multiplied by this, what do you get? Same base, you add the powers. If you add the powers, what do you get? You're going to get minus sine nx, and then this is dx, right? Because it's 2 plus 2, it's 2 plus n minus 2, so this minus this, you get 2, you get n. So from this point, what do we do then? So now remember, we said n is equals to the integral of sine nx, right, dx, which means n minus 1 will be the integral of sine n minus 1 dx, right? And also n minus 2 will be the integral of sine n minus 2 x dx, right, etc. So we are going to use this method to further simplify this expression. So here it's sine n minus 2, which means we're going to write this sine n, we're going to substitute this, right? So because this is still an integral that can be evaluated between these two expressions. So now we are going to have in is equals to minus cos x sine n minus 1x plus n minus 1, the integral, or let's just not use the integral anymore because we are substituting. So this is going to be n minus 2 minus in, right? Because the integral of sine n minus 2 dx is going to be this, and the integral of sine nx is going to be this. So now we have in on both sides, so we need to bring this in to the other side. But let me first work this out. You have n minus 1x plus, if we take this and open this bracket, we are going to have n minus 1 n minus 2 minus n minus 1 in, right? And then I'm going to take that side. We're going to have in plus, since it's minus here, right? It's going to be plus n minus 1 in is equals to minus cos x sine n minus 1 plus n minus 1 n minus 2, isn't it? So this is what we have, and then here I'm going to factor out in. So in, it's 1 plus n minus 1, right? It's minus cos x sine n minus 1x plus n minus 1 I n minus 2. And then here we can see that 1 minus 1 is, so we have n I n is equals to minus cos x sine n minus 1 x plus n minus 1 I n minus 2. So divided by n, so your I n, which is equals to the integral of sine nx dx, we are saying this is equals to minus cos x sine n minus 1 x over n, because we're dividing this n both sides, so plus n minus 1 over n I n minus 2, right? So now this is the general formula that you're going to use to reduce any integral of sine raised to the power any value of n. So let me just make an example. If you have I4 is equal to the integration of sine raised to the power 4 dx, right? So how do you evaluate this? This is equals to where there is n in this expression, you substitute 4. So this is minus cos x sine 4 minus 1x over 4. Obviously here 4 minus 1 is what? It's 3 plus 4 minus 1 over 4, which means this is going to be 3, right? And then 4 minus 2 is 2, right? And then this is going to be equals to minus cos x sine cubed x over 4 plus 3 over 4. What is I2? You use this one again, even for I2. It's an iteration I2. So in this formula where there's n, you substitute 2. So it's going to be minus cos x sine 2 minus 1x over 2. I'm here, and 2 minus 1, we know that is what? It's just 1, plus this is going to be 2 minus 1 over 2, which is 1 over 2. Then 2 minus 2 is 0. It's I naught. So now we are saying I4 is equals to, simplifying this, minus cos x sine cube x over 4 plus, evaluating this bracket, opening this bracket using this function, is going to be minus 3 cos x sine x over 4 times 2 is 8, and then plus 3 over 8 I naught. So now the question is, we're still not done. What is I naught? Remember, if we're saying I n is equals to the integral of sine nx dx, which means I naught is equals to the integral of sine 0 dx, right? And this is I naught is the same thing. Anything raised to the power 0 is 1. So the integral of dx, which is equals to x. So even here, so your final answer I4 is equals to minus cos x sine x over 4 minus 3 over 8 cos x sine x plus 3 over 8x plus c. So that's how we can evaluate sine raised to the power 4 using sine raised to the power 4 using the reduction formula. So this is the most important formula. This is plus c because it's indefinite integral. This is the most important formula. So even in the next video, we are going to look at how we can evaluate for cos and tan and also do examples that are related to those ones. So see you in the next video.